All right, let's get started. So just to recap, if you have a log, okay, there is a way to give an exact value. Some people will log both sides. Other people will do the inverse. Both is okay. But if I were to, let's say, log both sides, let's do the full solution, you get something like this. Following, using power law, you can drop down the exponent within a logarithm. There you go. And how do you isolate x? You would divide both sides by log 2, getting you log 14 over log 2. Right? So therefore, if I were to rewrite this as an exponent, 14 would equal 2 to the power of log 14 over log 2. That's what it would look like, wouldn't it? A little annoying, but that is how 14 can be written using exact numbers. Yes? The star is just a, hey, remember. It has nothing to do with the question. All right. Another way you can do it, if you were to do the inverse of 2 to the power of x equals 14, this becomes log of base 2. 14 is equal to the exponent x. And you know that x can be rewritten using change of base formula, log of 14 over log of 2. Exactly what we got on the left side. There's a variety of ways you can approach it. But please note that it is not about guess and check. You can write it using exact values. Okay? Same with this idea. I think I did this on Friday. So I'm just going to put a little star that says see Friday's notes. Okay, for decimal versus exact values. We did both. Okay? Which brings me to my science thing. So as promised, well, I don't know if I promised, but I do want to go through another half-life question officially. This equation is provided in your formula sheet, so you don't have to memorize it, but it's important that you know what number goes in where. Now, on Friday, I think I gave you a made-up example where was Hannah holding a party? Is that what it was? Okay, so Hannah was holding a party. There's a lot of situations where half-life comes into play. One situation that might affect you directly is Tylenol, right? The way Tylenol is broken down, because anything that's put into your body thinks is a foreign substance and is trying to digest it, even food. So Tylenol goes in, your liver's like, what the heck is this? And starts to break it down, break it down, break it down. And you see the amount of chemicals, acetaminophen, in your body begins to go down at an exponential curve. And so here it is. So shameless plug into sciences, right? If this is you, at 1 hour, you shoot up the amount of acetaminophen in your body. And it follows a half-life, and it begins to, after 3 hours, and then after another 3 hours, okay? And at this point, you're like, oh, I feel sick again. And so what do? You take another dose. And then at 3 hours, 3 hours, and so on and so forth. The same can be said about radioactivity, okay? And the same can be said about a whole bunch of different things, like coffee and caffeine. Let's put it this way. Okay, so going back to this idea of half-life. Why am I introducing this idea of half-life with iodine and thyroid? I'll ask again. Anyone know the connection between iodine and thyroid? So yes, your thyroid is in charge of producing a lot of good things for your body. A lot of good things for your body. It helps to heal your body, like the hormones and stuff. It helps to grow your body. It helps to develop brain. It helps to do a lot of things. It regulates certain hormones, okay, to keep you sane, for example. It's really, really important. However, some of the things that your thyroid is in charge of creating needs iodine. And so what does it do? If you eat something that has iodine, it'll go through and digest in your stomach, and then it spreads out and it gets absorbed into your body, and then the iodine gets slowly collected in your thyroid. Pretty amazing stuff. Now, where did we sort of ingrain this, and where do we sort of invent this? There are certain parts of, so I'll give you an example. I don't know if it's the exact story, but for example, there was a city or a town that was far off the coast where some people had an issue with their thyroid and some people did not. Okay? What they found was when the people died, they opened it up, it was a huge swelling of your thyroid gland, aka a goiter. Anyone heard of that before? Yeah, it's gigantic. Do I want to put up a picture? No, some people are like a little squeamish, okay? It's basically, think about it as a gigantic lump, and you're walking around with a big frog in your neck. It's pretty bad. How did that happen? Well, your thyroid is in charge of creating things, right? Now, creating things requires iodine. What if you don't have the building blocks to create it? Your body's like giving signals. Hey, create that for me, thyroid. What's wrong with you? The thyroid's like, I'm trying. And it doesn't create enough. And the body's like, I'm not getting it. Give me more. Like, I'm trying. What happens when you work out? You lift heavy weights. Your muscles rip. And as the muscle heals, what happens to your muscles? It gets big. This is one of those big people where they can't even put their arms together. You know what I mean? Okay, it gets bigger and bigger. The same thing happens with your thyroid. It damages itself and it heals. And then it damages itself and it heals. And it repeats that process. They found, why is it that some people get the goiters and some people don't? And if you look at the people that live on the coast, they don't get it either. They made the connection that these people with goiters were lacking in iodine. So how is that related to people that live on the coast? Their diet. Yeah. Right? So if any of you have ever bought table salt for the family in grocery shopping, you might see a little label that says iodine infused. Because if we didn't have that infusion, all of us, unless we're eating lots of sushi, will probably have goiters. So with that connection, why am I telling you this? With that knowledge, here's what we do. If we wanted to check your thyroid for whatever reason, the doctors would give you radioactive iodine to drink. You literally just chug it. And it's not harmful, okay? It's not harmful iodine, not like the iodine that you would rub or the stuff that you would find in a chemistry experiment, okay? It's not that rubbing stuff. It is safe versions of ions, of iodine. It will get ingested, spread through your body, and then your thyroid slowly collects it. But it's radioactive. What does that mean? Yep. It'll show up on X-ray? Yeah. It's pulsating invisible light from your neck. So if we had like X-ray vision, right? Someone that has ingested that, they would shine light like constantly. It'd be pretty wild, okay? But in doing so, when they take a picture using a special camera that detects energy, your thyroid shows up very beautifully. It's pretty cool stuff. Science. It's sort of like half my studies and stuff. Okay, that's why I put it in there. Anyways, why am I telling you this? Just because I want to. That has nothing to do with the math. Your responsibility is to know how to use this formula and solve it using your knowledge of logarithms. So here we go. A final. A initial. Half T over 2. In this case, we are starting with a 100 milligram injection. If this much is left in the body after 1 day, what is the half-life of the radioactive iodine I-131? I think it's good to know the context of why you would ever ingest iodine. So 91.7 is how much is left. 100 milligrams is how much I start with. Since we're dealing with half-life, the base is half, 0.5. Time, actually no time. Time is 1 day, but you can set the time to be any unit you want. So do we want days? Do we want hours? Do we want minutes? Do we want seconds? Do we want years? Do we care? Hours, we can. Days, we can. Just keep it at days? Sure, it doesn't matter. So use what unit is easiest for you. If time is in days, know that the answer that I get for half-life will also be in days. If this is in days, then that also is going to be in days. So let's start it. 91.7 equals 100 times this. I will divide 100 from both sides. And this is your exponent. Solve it. In grade 11, this was guess and check because logarithms was outside of the mathematical curriculum. But now we should have our techniques and tools to isolate for the exponent. I'll give you, I'm going to say 30 seconds. I'll give you 30 seconds. Okay. Judging from the two people that I looked at, the general strategy that I am seeing is that you are going to log both sides so you can drop down the exponent. That's totally fine. So I am going to log 0.917, and I am going to log 1 over 2 to the power of 1 over lambda. And since this exponent is within the log and there is only one base, I can follow that formula and say 1 over lambda is equal to, 1 over lambda times log of half is going to equal that. If you did it a different way, it's totally fine. But here it is. If that is the case, how do I get 1 over lambda all alone? Divide both sides. I have log of 0.917 divided by log of half. I'll just write it as a decimal. And if something over something equals 1 over lambda, it is not wrong to say the reciprocal of one side is equal to the reciprocal of the other. You plug this into the calculator, lambda will be approximately 7.9999, which is approximately 8 days. Why is it days? Because we use time as days. Yes?
Everyone says, like, teachers say that lambda is half-life. What does that mean?
It means how much time does it take to get to half of what it was before? So think about it. If this is 8, how many days do I have to wait until I can multiply by 0.5? In other words, how many days do I have to wait for this exponent to turn into 1? That's right. So if the division is 8, I have to wait 8 days until I have an exponent of 1. So it sort of works out that way. Yep.
Do you always have to add log to both sides, or like could I just add it to that both sides?
If you are bringing something in, it has to be done to both sides as an equal sign, as an equation. Okay, so 8 days. With that said, I gave you a quick example of Tylenol just earlier today. Can you take a guess? What is the half-life of Tylenol? In other words, you pop an extra strength, that's 500, 500. Yep. It does say to take it every 4 to 6 hours. That 4 to 6 hours, because humans are different, right, is approximately 2 cycles. So what is the half-life? 2.5 hours, that's right. So as Tylenol, again, a shameless plug into the sciences. Okay, you get your medicine. That's about 500. It goes to about 250 in 3 hours, and then it goes to what's half of 250? 125 in 6 hours. And that's too low. You have 75% gone and 25% remaining because it's half of half, right? You lose 50% and then you lose another 50%. So it's actually 50% and then 25%. Half-life. Sorry, it's a terrible drawing. So in 3 hours, you lose 50%. So that's 250. Half-life is half of what's in your body. It's exponential. And so what's half of 250? 125. In another 3 hours, you lose half of that. That's right, you have 25% left. And so that's too low. You have only 125 in your body. So you take another pill and bring it up to 125 plus another pill. And then half is lost, and then half is lost. So you feel sick again. So you add another pill. Half is lost, so on and so forth. Yes?
Is that where they say not to take it to like over a certain amount in 24 hours because it keeps going higher each time?
Yes and no. It keeps on going, but at a certain point, the 500 that you add will be equal to the 75% that you lose. So you actually meet a certain stable state, I think is the word that we used in university, right? We meet a point where it's safe, it's not too high, but it doesn't go below. So you feel healthy always during that 6 hours. At a certain point, I think the line is somewhere around here. Anywhere under that line, you don't feel it. And then your safety limit is really, really high. So you don't actually get sick. There was a story of a doctor that said someone tried to commit suicide by taking a lot of Tylenol. It was the most excruciating thing because Tylenol is digested half-life wise. So it doesn't kill, it just hurts. And that's just painful. That's really, really sad story. But anyways, the point was trying to make this idea. So why then, life lesson for you, why then do they say don't take more than seven days? Don't take Tylenol for more than 7 days. If you're not going to get sick. There's two reasons. One, yes?
I don't know. When I had a concussion, I kept taking Motrin. My doctor, like I said, I kept having headaches. So my doctor was like, okay, you need to stop taking the Motrin.
Mm-hmm.
She's like, your body's getting like used to it and it kind of wants it. I don't know if that's kind of connected. But...
That's a little different. We could talk about the psychology of quote unquote addiction. That's not quite related to your liver. The idea is this. If Tylenol isn't helping, so in other words, Tylenol is not a bacteria killer, it's a pain relief. And so your pain is being relieved while your body naturally fights your cold. So if your body is not able to fight a cold after 7 days, it's not a cold. It's something else. So go get it checked. Okay, that's number one. Number two, Tylenol is broken down by a very special kind of enzyme in your liver. Your liver has a limited amount of that enzyme. You don't want to deplete this enzyme in your liver. Otherwise, remember the story of the goiter? You don't want your liver to be overused. I mean, your liver is never overused. Your liver is only used, like 10% of your liver is only used at one point in time. So it's not like it's a risk, but it can damage it if there's no enzyme to metabolize acetaminophen. Okay? Case in point, if you are taking Tylenol and someone says, oh, vitamin C is good for you, please do not take Tylenol and grapefruit at the same time. grapefruit and Tylenol is metabolized by the same enzyme. And so you are depleting your liver faster than 1 week. Okay? Life lesson. Let's move on. Go back to math. I have example 4. So example 4, these two are basically the same situation. Example 5 is slightly different. And then this is not in your page, but I thought I would add it in there. So I added it a little late. 2x plus 7 minus 2x minus 508. Not 9. I want to solve everything here for you. Let's do do the first one. I am going to let you try the second one. I'll help you set it up. And then part C, or example 5, can be a little challenging. I'm going to force you to try it. And then I'm going to force you to try it. And then we'll call it a day. Okay, let's do this. Solve. Doesn't that look somewhat familiar? I have 3 to the power of 2x plus 3x equals 20. It might seem a little familiar, but clearly it's different. Our goal, my hope for you, is that you can look at these questions and manipulate it using your exponent and log laws so that it helps you. I'll give you 30 seconds. How could you go about solving this? It's a very simple fix. For those of you who are stuck, what if I rewrote the question like that? Because an exponent of 2x is exponent of x to the power of 2. Some of you are starting to write. Right. Here's my next hint. Why not? I see something squared plus the same thing minus 20. All of a sudden, doesn't that look familiar? Go ahead. Try to solve it. I'll give you a minute. All right, let's try this. So the factoring, I believe, is not the main challenge here. It's, okay, where is that going? So this is unfamiliar territory, right? A equals -5 or A equals a +4. But that means 3 to the power of x equals a -5 and 3 to the power of x equals a 4. If you remember your logarithms, you can immediately reject this because there is no solution to it. Why? Yep. Yeah. So I can defend that answer, defend that point with the exponent, with the graph. Okay? If you have any kind of exponential function, you know that there is an asymptote and we do not cross it. Right? There is no negative value, so this is impossible to find. So there is no solution. You don't have to explain yourself. You immediately just reject it. So that means here I have log of 3x equals log of 4. Power law, drop the x down. X is equal to log of 4 over log of 3. That's the answer. Yes?
Wouldn't that just be log 3 or log base 3?
Yep. Or you can say x is equal to log 4 of base 3. That's right, same thing. Okay? So we're not going to solve the next one, but I'd like you to think about how we can manipulate that to make our lives a little bit easier. Again, it's a very quick fix. So I'll give you 30 seconds to try it. I wonder, did you get it? So obviously the daunting part is a square root. Even the 2x, sure, that's a little annoying, but now there's a square root to it. That's okay. I'm going to replace that entire thing because it seems common. Therefore, I have a minus 12 over a equals. What's the next annoying part about this? I'm hoping you're thinking it's the fraction, and that's okay. How about we multiply everything by that variable? And all of a sudden, we have a squared minus a minus 12 equals 0. Which should be familiar. Please note, because the denominator is as such, a cannot equal a 0. So square root of 2x cannot equal a 0. Okay? And the rest you can solve. So I'll leave that to you. I'm going to leave that for you to try. Okay? You have plenty of class time to look at it again. I am more curious of how you might approach the next question and manipulate it to make your life easier. Question?
You still have to put that restriction because it can never equal 0 already, like without having to say it.
Well, that's what I'm. Yeah, this is where it's coming from. Yeah. So if at any point you have a value, oh, I see what you mean. The exponent will never be a 0, so I don't have to worry about a square root of a 0. You're right. I guess not. It will show itself as an impossible answer. You're right. So this might be redundant. Fair. Good point. Okay. All right. Here's a weird one. I'm going to give you a chance to see if you could, again, manipulate this to the best of your abilities. See what you got. And obviously the focus is a negative power. I don't like that. I want to know how you might approach this. I can already see you doing it in two different ways. Some of you might want to do it like this, saying like, yeah, I can see that. Or I have another proposition for you just to open your eyes. And then we will do that homework question together. Okay? See what you got. Go all the way this time. All right. So let me try to show the two different creative ways that you can approach it. I've seen a lot of people do this. They wrote 2x minus 1 over 2x, right? Because that's the exponent. And so that becomes a minus 1 over a equals 4, very similar to what we did before. Let me provide another one, another solution that you may not appreciate per se, but it may come in handy if I give you a different situation. And that is, I am going to actually multiply both sides by 2x to the power of x. Why? Essentially, I don't like that negative. Consider this. If I multiply both sides by 2x.
Miss Wong, can you please make your way to room 123? Thank you.
This is 2 to the power of x times itself. But, oh, shoot. I forgot this one too. Oh, wait, 4 times 2 to the power of x. Okay. What is this? What is 2 to the power of x times 2 to the power of negative x? What do you do to the exponents? So when you add and subtract the same number, you're going to get 0. Okay, so let me bring 4 times 2x to one side. I get myself a squared minus 4 times 2x minus a 1, which is the same thing as what you would get here. It's all the same. But this is not factorable. So let's do it. I will check to see if this exists. B squared minus 4 times A times C. Ooh, it does exist. Oh well. Therefore, A is equal to negative B plus minus root 20 over 2A. Which I am going to simplify. 4 divided by 2 is 2, and 20 divided by 2 is like saying, sorry, root 20 divided by 2 is like saying root 20 divided by root 4. The answer is just plus minus root 5. Therefore, okay. So here you would take this and just solve for x based on whatever skills you have with logarithms. So consider this part might have been a little bit unusual, but if that was factorable, you would do the same thing, right? A is equal to something, A is equal to something, that means 2x is equal to something, 2x is equal to something. One is rejected because there's no solution, because 2 minus root 5 is a negative. And this one you can solve with logarithms. Yes?
How did root 20 turn into root 5?
So the question is, how did root 20 over 2 become root 5? As I was saying here, root 20 divided by 2 is the same as root 20 divided by root 4. Okay, so let's do it. My final question, so I'm going to leave you with this. If you are interested, you can look back at the board. If you are not interested, just tune out. I rewrote this on a blank piece of paper here. Okay. I'm going to ask you to try it. And I'll tell you right now, the reason I want to show this to you, this one is completely different from a trinomial that you factor. So I'm telling the hint is, this is not a trinomial that you will factor. It's something else. It's another kind of question that you might see. So see if you can do it. I'll pause the video once again. And for those who are interested, tune in about 5 minutes. Yep. Yeah, go for it. All right, I think that was long enough. Here's it is. Once you see it, you're like, oh, we could do that? Because I'm not going to be doing anything special. X plus 7 as an exponent could be the same as that. Because if you have that, we can factor so that we have only one x value to deal with, as opposed to seeing it in multiple locations. We factored out. The bracket solves as 128 minus 1, so 127. And then this becomes simple. How do I get 2x all alone? Divide both sides by 127. Answer is 4. So the x is just 2. It's simple when you see it. But at the start, if you don't have an idea of how to deal with that unusualness, it is challenging. Because there's only one route you can take. All the other ones are very, very complicated. Please don't fall into the trap of logging both sides by log, log, and log. Okay, all 3 of them don't become logged separately. It's a little different. If I have x plus 2 equals 5, and I log both sides, it is log of all of this equals log of all of that. It is not log of x plus log of 2 equals log of 5. It is not that. Super important that you make the distinction. Why? Because log of x plus log of 2 using our product law is also the same as log of 2 times x log of 5, right? This and that can be multiplied if this is the case. And that clearly is not the same. Anyways, that brings an end to what we have today. Once again, I'll remind you that the quiz review is already there in front of you. Tomorrow, during our half day, I'm just going to give you some extra practice questions with product and division or quotient law, something that we've already seen before. All right?